Let's deep dive into the chat app and see if it scales for our numbers or not. In a basic chat system, what we want is to have a user send a message to our backend servers. Our server will further forward the message to the recipient. Now, if we look into this component, how exactly will the message go to the recipient? It's not the recipient's phone has a server internally which can accept and process incoming requests. So how can we solve this? Perhaps at the client end in the app itself, we can write a custom polling logic. This will keep polling our server for any new messages and display it client side when found. The problem here is we don't know how frequently to poll. There will be a certain interval between the next poll request. This will add latency to our app and the communication won't be real time at all. Since we are polling here continuously, in most of the cases, a regular user would not find any messages on polling, especially at night when they are sleeping. This means we are unnecessarily wasting the client resources in the background. Due to these problems, this way of pulling the data from servers isn't really efficient. So let's see if we can instead somehow push the messages from our server directly to the client app. For the client app to be able to receive an incoming message, it will have to keep a connection open. By sending messages on demand, we will be able to minimize latency and no resources will be wasted. Now, how exactly can we implement this? We can perhaps try long polling in which the recipient keeps a connection open. Whenever the server receives a message, it will forward it to the recipient. This connection can be kept open in the background. Since we need to push messages from server to recipient app, we need only one-way communication, and so long polling is a perfect use case for this. However, what happens when both the sender and recipient have opened the chats and are sending messages to each other back and forth? Long polling might still work, but since it is a unidirectional approach, can we improve the efficiency by perhaps a bidirectional approach? Well, luckily, WebSockets are perfect for this use case. When both the clients have their app opened, the first time one of them sends a message, we can establish a WebSocket between them over which they can send and receive messages. So we need a combination of both the long polling and WebSockets to solve this. Now, since we need to find the connections of clients to send messages to, we will need to store these in a database. Let's see how we can scale this for so many users. So let's say user 1 sends a message to another user. We can have a dedicated service to manage these connections. Let's call it Session Manager. The request goes to Session Manager, which should be able to find the connection reference of the recipient. Since a session will be need to be stored for each user, a hash table looks like a good data structure for our use case. The key of hash table will be a unique user ID itself, and the value will be the connection object. Looking up at the recipient session would be quite straightforward. If down the lane we get any scaling concerns for this, we can distribute the hash table over multiple servers along with consistent hashing and use a hash function for the lookup.